Welcome to Mind Atlas, the place where curiosity meets knowledge and where we dare to explore the mysteries that lie beyond our imagination. Imagine a time before time itself, a moment when nothing existed. No stars, no galaxies, not even space. Then, in an instant smaller than the tiniest speck, everything ignited. The universe burst into being in a blazing explosion we call the Big Bang, sending matter and energy hurtling across the void. From this cosmic spark, galaxies were born, stars ignited, and planets began to take shape. Forces beyond our comprehension sculpted the heavens, creating order from chaos. And yet, even now, billions of years later, much of the universe remains hidden from our eyes, cloaked in darkness, mystery, and awe. Have you ever wondered what it feels like to travel through time itself? To witness the birth of a star, or to stand at the edge of a black hole where space and time twist into the unknown? What secrets are hidden in the depths of space, waiting for humanity to discover them? Tonight, we journey across the cosmos, from the very first spark of existence to the enigmatic black holes that challenge everything we think we know. We will explore the unseen, question the impossible, and uncover truths that might change the way you see reality itself. So, fasten your seatbelt, open your mind, and prepare for a journey like no other. This is Mind Atlas, and together, we will unlock the secrets of the universe. Imagine a universe that didn't exist. No stars, no planets, no space itself. Then, in an instant, everything changed. About 13.8 billion years ago, the cosmos emerged from a single, unimaginably dense point called singularity. This singularity was smaller than an atom, yet it contained all the matter, all the energy, all the potential of the universe compressed into a point so extreme that the laws of physics, as we know them, could barely describe it. And then, the Big Bang. Not an explosion in space, but an explosion of space itself. Space stretched, expanded, and ballooned outward at unimaginable speed, faster than the speed of light. This was the birth of the cosmos. Within the first trillionth of a second, the universe swelled from smaller than a proton to the size of a galaxy cluster. Temperatures were hotter than the core of a star, and energy transformed into matter in a cosmic dance of creation. Quarks, electrons, and neutrinos zipped through the newborn cosmos, colliding and combining to form the first simple particles. As the universe expanded, it also began to cool. Within the first few minutes, protons and neutrons fused in a process called Big Bang nucleosynthesis, giving birth to the first atomic nuclei: hydrogen, helium, and trace amounts of lithium. These were the first building blocks of everything: the stars that would shine, the planets that would form, and eventually life itself. Think of it like a cosmic soup, bubbling, chaotic, yet full of potential. Every atom in your body today was forged in this early cosmic furnace. Every star in the night sky, every distant galaxy, traces its origin to this extraordinary moment of creation. And yet, even after this tremendous beginning, the universe was a dark, opaque place. For hundreds of thousands of years, the universe remained opaque until a gradual transformation began. As the cosmos expanded and cooled, electrons and protons combined to form neutral atoms, allowing photons to escape their entrapment. The universe became transparent, and light finally streamed across the vast expanse, revealing the first glimmers of structure amidst the chaos. Photons, the particles of light, were trapped in a fog of plasma, unable to travel freely. It would take hundreds of thousands of years before the universe became transparent. allowing light to stream across the cosmos and revealing the first glimmers of structure in an otherwise chaotic universe. This is the story of our cosmic origin, a violent, beautiful, and awe-inspiring beginning that set the stage for everything we know and everything we are yet to discover. As the universe continued its expansion from the Big Bang, gravity began its incredible cosmic dance. Tiny fluctuations in the distribution of matter became the seeds of something extraordinary. Imagine invisible threads of gravity stretching across the dark void, gently tugging clouds of gas and dust together. These clouds grew denser over millions of years, forming the first cosmic neighborhoods, the primordial clumps of matter that would become the first stars. Within these dense pockets, hydrogen and helium atoms collided and compressed under their own weight. The pressure and heat built up until something magical happened. Nuclear fusion ignited, and the first stars came to life. They burned brighter than anything we can imagine, lighting up the darkness of the early universe. Some were massive giants, hundreds of times larger than our sun, living brief yet spectacular lives. Others were smaller and steady, destined to shine for billions of years. But stars rarely form alone. Gravity pulled them into clusters, creating early star cities, or what we now call galaxies. These galaxies varied in shape and size. Some were elegant spirals, like our Milky Way, gracefully spinning their arms in the cosmic ballet. Others were massive, chaotic blobs of stars and gas, colliding and merging to form even larger structures. Within these galactic cradles, stars danced in complex orbits, forming families of solar systems. Heavy elements forged in the cores of massive stars were released in explosive supernovae, seeding the interstellar space with the building blocks for planets, moons, and eventually life itself. Every galaxy is a story of gravity, energy, and cosmic creativity. Our own Milky Way is just one of billions, a swirling masterpiece of over 100 billion stars, each with its own planets, moons, and mysteries waiting to be discovered. And the process didn't stop. Galaxies collided, merged, and evolved, sculpting the universe into the vast and intricate cosmos we gaze upon today. It's a universe alive with motion, light, and endless wonder. A universe that continues to grow, change, and surprise us at every turn. Stars are the universe's ultimate furnaces, colossal engines of light and energy that shape everything around them. Imagine a small star, like our sun. For billions of years, it quietly burns, fusing hydrogen into helium at unimaginable temperatures, tens of millions of degrees at its core. This process releases energy that lights entire solar systems, including our own, and sustains life on Earth. In a way, every sunrise we witness is thanks to the fusion within our star. But not all stars live such long, peaceful lives. The massive ones, stars many times the mass of our sun, live fast and burn hotter. Their brilliance is intense, but their lifespan is fleeting, sometimes just a few million years. When they run out of fuel, gravity wins the battle, collapsing the core and triggering one of the most spectacular events in the cosmos, a supernova. Picture it, a single star outshining an entire galaxy for a brief moment. In seconds, it ejects vast amounts of matter into space, including elements like carbon, oxygen, iron, and even gold. These are the very elements that form planets, oceans, mountains, and even the atoms in your body. In other words, we are literally made of stardust. But the story doesn't end there. Some stars, after exploding, leave behind neutron stars, unimaginably dense remnants where a teaspoon of material weighs billions of tons, or even black holes, regions where gravity is so strong that not even light can escape. Fun fact, some massive stars experience a rare, dramatic outburst called a hypernova, producing gamma-ray bursts that can release more energy in a few seconds than the sun will in its entire lifetime. These cosmic fireworks remind us of the raw power and mystery of the universe. Every star, whether small or massive, has a story, a life cycle that not only illuminates the cosmos, but also seeds it with the very building blocks of life. The next time you look at the night sky, remember, each twinkling star is a furnace, a storyteller, and a creator, and some of its material is inside you. As the first stars ignited, their immense gravity began to pull in surrounding clouds of gas and dust. These clouds didn't just disappear. They started spinning, forming swirling disks around newborn stars. Within these cosmic whirlpools, dust grains collided and stuck together, slowly building pebble by pebble, rock by rock. Over millions of years, these tiny clumps grew into planetesimals, the seeds of future planets. Some of these worlds became rocky, like Mercury, Venus, Earth, and Mars, forged in the furnace of proximity to their star, baked by its heat and sculpted by intense collisions. Others, farther from the stellar warmth, collected thick layers of gas, becoming the giants we know as Jupiter, Saturn, Uranus, and Neptune. Imagine the sheer chaos of this time. Collisions creating mountains, craters, and molten oceans as gravity played its cosmic game of sculpting worlds. Some of these early planets were destroyed entirely, while others survived, slowly finding stable orbits. It was like watching the universe play a game of cosmic billiards. Some planets knocked out, some locked in perfect harmony. But it wasn't just planets. Around these stars, moons formed, captured from passing debris or born from colossal impacts. Rings, asteroid belts, and comets. Icy travelers from the outskirts, added drama and beauty to the system. Our solar system, for example, is full of these remnants of chaos. The asteroid belt between Mars and Jupiter, the icy Kuiper belt beyond Neptune, and comets that occasionally grace our skies with spectacular tales. Every solar system tells a story, and no two are exactly alike. Some stars are orbited by dozens of planets. Others have hot Jupiters hugging tightly to their sun. And even in this immense diversity, a pattern emerges. Gravity organizes chaos into order, creating a delicate cosmic dance that can last billions of years. Think about Earth, orbiting perfectly at just the right distance from the sun. Not too hot, not too cold, with liquid water, a protective magnetic field, and an atmosphere capable of nurturing life. In this vast universe, our solar system is just a tiny speck, yet is a reminder that amidst cosmic chaos, order and beauty can emerge. Imagine looking out into the night sky, counting stars, galaxies, and clusters of cosmic wonders. You might think you're seeing the entire universe. But what if I told you that everything you see, all the stars, planets, gas clouds, and galaxies, makes up less than 15% of the universe? The rest is invisible, hidden, mysterious. This is the realm of dark matter and dark energy, the invisible forces that control the destiny of the cosmos. Let's start with dark matter. Unlike the matter we're familiar with, the stuff that makes up planets, people, and stars, dark matter doesn't emit, absorb, or reflect light. You can't touch it, taste it, or see it. So how do we even know it exists? Gravity. The galaxies are spinning, twisting, and moving in ways that visible matter alone cannot explain. If we calculate the mass of all the stars and gas in a galaxy, it should fly apart as it spins. Yet galaxies stay together, their stars holding firm, as if something invisible is acting like a cosmic glue. That invisible glue, that unseen scaffolding holding the universe together, is dark matter. Scientists estimate that dark matter makes up around 85% of all matter in the universe. Without it, galaxies would not form, stars would not cluster, and the universe as we know it would collapse into chaos. But just when we think we understand one cosmic mystery, the universe throws another puzzle our way: dark energy. While dark matter holds galaxies together, dark energy does the opposite. It pushes the universe apart. Imagine the universe as a giant balloon. The galaxies are dots on its surface. Dark energy is like a mysterious force that keeps inflating the balloon, stretching space itself faster and faster. Here's the mind-blowing part. Dark energy makes up roughly 70% of the total energy in the universe. It is literally the dominant component of reality, and yet we have no idea what it actually is. Think about it. Nearly 95% of the universe is invisible. And everything we see, the stars, planets, and galaxies, is just a tiny fraction of the whole story. Dark matter and dark energy aren't just scientific terms. They are the invisible architects and mysterious engines of our universe, silently shaping the cosmic landscape, dictating the fate of galaxies, and guiding the ultimate destiny of everything that exists. And perhaps the most exciting part? Humanity has only just begun to peel back the layers of these cosmic secrets. The more we discover, the more the universe whispers, there's so much more to see. Black holes are among the most mysterious and mind-bending objects in the universe. Imagine a place in space where gravity is so overwhelmingly strong that nothing, not even light, can escape its pull. Yes, not even light. This is why they are called black holes, because they are invisible, hidden from view, yet their presence is revealed through the extraordinary effects they have on their surroundings. Most black holes are born from the dramatic deaths of massive stars. When a star many times larger than our Sun exhausts its nuclear fuel, it collapses under its own weight. The outer layers explode in a brilliant supernova, while the core shrinks into a point of almost infinite density called a singularity. Surrounding this singularity is the event horizon, the point of no return. Cross it, and you're trapped forever, pulled inexorably toward the center. But not all black holes are born from dying stars. At the hearts of most galaxies, including our Milky Way, lie supermassive black holes, millions or even billions of times the mass of the Sun. These cosmic giants govern the motion of entire star systems, orchestrating the dance of stars and shaping the very structure of galaxies. Imagine a conductor guiding a vast symphony of celestial bodies. That is the role of a supermassive black hole. Black holes don't just swallow matter, they warp reality itself. According to Einstein's theory of general relativity, a black hole bends space and time around it. Time near a black hole moves slower than it does far away, a phenomenon called time dilation. If you were to hover near the edge of a black hole, years could pass for the rest of the universe while only minutes pass for you. And the strangest part? Some black holes are spinning at incredible speeds, dragging space along with them. These spinning black holes can form jets of superheated matter that shoot across galaxies at nearly the speed of light, producing some of the most energetic phenomena in the universe. For decades, black holes were theoretical curiosities. We couldn't see them directly, only infer their presence from the behavior of nearby stars and gas. But in 2019, humanity captured the first ever image of a black hole shadow, a glowing ring around the darkness, using the Event Horizon Telescope. A visual confirmation of one of the universe's most enigmatic monsters. Black holes challenge everything we know about physics. Inside a singularity, the laws of general relativity break down, and quantum mechanics takes over, a frontier scientists still struggle to understand. Are black holes gateways to other universes? Could they contain hidden dimensions? Or do they simply vanish, leaving behind the mysteries of the cosmos? In essence, black holes are not just cosmic monsters. They are the ultimate laboratories of the universe, stretching our imagination, testing the limits of physics, and reminding us how small and fragile we are in the grand cosmic tapestry. They are dark, dangerous, yet awe-inspiring, a true emblem of the universe's most profound secrets. Not all stars end their lives quietly. Some massive stars undergo a spectacular collapse, compressing matter so intensely that they form neutron stars, cosmic objects so dense that a single teaspoon of their material would weigh billions of tons, heavier than all of humanity combined. Imagine holding that teaspoon in your hand. If you could, you'd be flattened instantly by its unimaginable gravity. Neutron stars are the ultimate laboratories of physics. Their cores are packed with neutrons squeezed together, a state of matter that cannot exist anywhere on Earth. It's a realm where our normal understanding of physics is pushed to the very edge. But the wonders don't stop there. Some neutron stars spin incredibly fast, up to hundreds of times per second, and beam powerful electromagnetic radiation from their magnetic poles. These are called pulsars, and they act like cosmic lighthouses, sending precise signals across the galaxy that scientists can detect even millions of light years away. Then there are magnetars, neutron stars with magnetic fields 1,000 trillion times stronger than Earth's. A magnetar could wipe clean all electronics on a planet from thousands of miles away, simply with its magnetic force. And let's not forget quasars, the brightest, most energetic objects in the universe. Powered by supermassive black holes at the centers of distant galaxies, quasars emit more light than trillions of suns combined. They're beacons from the early universe, letting us glimpse the cosmos as it was billions of years ago. Together, neutron stars, pulsars, magnetars, and quasars showcase the extreme and almost unbelievable possibilities of the universe. They remind us that the cosmos is a place of extremes, where energy, gravity, and matter dance in ways that challenge our imagination and expand the limits of human understanding. Amidst these cosmic marvels, a question has fascinated humanity for centuries. Are we truly alone in the universe? Consider this. Our galaxy, the Milky Way, contains over 100 billion stars, and most of these stars are likely orbited by planets. Some of these worlds lie in the so-called habitable zone, where conditions might allow liquid water, the essential ingredient for life as we know it. Imagine oceans under alien skies, with skies colored differently than ours, and landscapes shaped by forces we have yet to comprehend. And it doesn't stop there. Thousands of exoplanets, planets outside our solar system, have already been discovered, with some even in systems that are hundreds or thousands of light years away. Some are rocky like Earth, some massive and gaseous like Jupiter, and others so bizarre that they defy our imagination. Planets where it rains glass sideways, or worlds tidally locked so one side scorches while the other freezes. Scientists are now searching for biosignatures, chemical clues in the atmospheres of distant planets that could indicate life. Signs like oxygen, methane, or unusual combinations of gases might reveal the presence of microorganisms, or even complex life, far beyond our solar system. And let's not forget the possibility of life in unexpected places closer to home. Beneath the icy crust of moons like Europa and Enceladus, oceans may swirl, warmed by tidal forces and rich in chemical nutrients. Microbial life could exist there today, hidden from our eyes, proof that life finds a way even in the harshest corners of the cosmos. This search pushes science to the very edge of imagination. Could there be civilizations broadcasting signals across the stars? Could intelligent life be observing us as we observe them? The famous Fermi paradox challenges us. If the universe is teeming with life, why haven't we encountered it yet? One thing is certain. Every new discovery brings both answers and even more questions. Life in the universe remains one of the most thrilling, mysterious, and inspiring frontiers of human curiosity. Perhaps the day will come when we finally look up and know, without a doubt, that we are part of a cosmic community. As we peer into the cosmos, a question looms larger than any star or galaxy. What is the ultimate fate of the universe? Will it continue expanding forever, slowly fading into cold darkness? Or will it one day collapse in a cataclysmic event, crushing everything back into a singularity? Perhaps the universe holds secrets so strange, even our imaginations cannot grasp them. Scientists have proposed several mind-bending scenarios. One possibility is the Big Freeze. Imagine a universe that keeps stretching, galaxies drifting farther apart, stars burning out one by one. Slowly, over trillions of years, the cosmos could become a cold, dark, silent place, a cosmic graveyard where energy is so diluted that life, as we know it, could no longer exist. Then there's the Big Crunch, the dramatic opposite. If gravity eventually overcomes the expansion, all matter and energy could collapse back into a single point, a singularity, where time and space, as we know them, cease to exist. Some theorists even suggest a big bounce, where the collapse triggers a new Big Bang, giving birth to an entirely new universe, a cosmic cycle without end. And let's not forget the mysterious role of dark energy. This invisible force, driving the universe's accelerated expansion, might lead to an even stranger fate, the so-called Big Rip. In this scenario, galaxies, stars, planets, and eventually atoms themselves could be torn apart as space expands faster than light itself, ripping the fabric of reality. These possibilities are not just scientific hypotheses. They are philosophical mirrors, challenging how we think about existence, time, and our place in the cosmos. Are we witnesses to an eternal universe, or travelers through a fleeting cosmic moment? Will our descendants look up at the stars in a universe that is growing colder and darker, or will new beginnings rise from the ashes of cosmic collapse? The future of the universe is a story of mystery, wonder, and awe, a reminder that, no matter how much we learn, the cosmos remains bigger, stranger, and more beautiful than we can imagine. And yet, within this vast and uncertain universe, we exist, conscious, curious, and capable of exploring its secrets. Perhaps that is the most astonishing part of all. From the fiery birth of the universe to the mysterious and mind-bending nature of black holes, we have traveled across space and time, witnessing the raw power, beauty, and complexity of the cosmos. The universe is not just vast, it is almost impossibly immense. Imagine trillions of galaxies, each with billions of stars, swirling in an intricate cosmic dance, all connected by invisible threads of gravity and energy. And yet, in this grand expanse, here we are, tiny, fragile, and yet incredibly special. Every atom in your body was forged in the heart of an ancient star. The very essence of life on Earth is, in a very real sense, stardust, a direct connection to the universe itself. You are not separate from the cosmos. You are a living part of it. The story of a universe is also the story of curiosity, of exploration, of questions that lead to answers, and answers that lead to even bigger questions. It is a reminder that knowledge is not static, it is an adventure, one that invites us to think beyond our daily lives, to dream bigger, and to seek understanding in the face of the unknown. Look up at the night sky tonight. Every twinkling star, every faint smudge of a distant galaxy is a beacon of history, a messenger from the past, a symbol of infinite possibilities. The universe is alive with stories waiting to be told, forces waiting to be understood, and mysteries waiting to ignite your imagination. So, what is our place in all of this? Perhaps it is to explore, to learn, to marvel, and to never stop asking questions. Perhaps our purpose is to witness the wonders of the cosmos, to reflect on our small yet remarkable existence, and to celebrate the miracle of life amidst the vastness of space and time. Thank you for joining this cosmic journey with Mind Atlas. Remember, every day is an opportunity to expand your mind, explore the unknown, and connect with the universe in ways both big and small. Don't forget to subscribe and hit the notification bell, because the adventure is just beginning and there are countless mysteries waiting to unfold. Until next time, keep looking up, keep wondering, and always remember, the universe is not only out there, it is also within you.